Okay, so this is our first one. And the next one only has like 20 something slides in it. So that one's going to mush in there pretty easily. So just stop me or make questions if I have anything. Yeah, good job, Stephen. Thank you for not breaking anything. And also thank you for the knock on wood. All the superstition can help sometimes. Okay, so implementing remote access. I'm going to remove my gum so you guys can actually hear me. Okay, an overview of remote access. So remote access is a server role that provides services to keep mobile workforce and branch offices securely connected to resources at the main office. Oh, German, did you say you're having problems with your VM? Are you able to get to your VM? Okay, good. I was gonna say, I know that we had you were the one that I had on the email chain that they got fixed. That was yours, right? Somehow it got itself into the work group. Okay, yeah, I was gonna say I thought that was you. I was hoping it wasn't someone else's did the same thing. So I was like, okay, let's hope that's not a pattern that we're seeing. So yeah, if anybody has any problems with their VMs, let me know ASAP so that you can get them fixed. Mindy and William, our networking guys, have been really good about getting back to those very quickly. Okay, reasons for using remote access solutions are work from home employees, frequent traveling business partners, and branch offices. Remote access services and tools. So we have VPNs, the virtual private networks, remote dial-in, routing, network address translation, or NAT, and direct access. Remote access server role has additional features, but the list above are the core services for most remote access needs. Installing and configuring remote access roles. So remote access role is installed by using Server Manager or the install Windows feature with PowerShell commandlet. And then under the main remote access server role, there are 3 role services to choose from. And I have my cat's decided to sing, so I apologize if you hear random meowing. That's just her having a little concert in the background. Okay, so first we have direct access and VPN. RAS has features needed for dial-in, VPN, and direct access remote access. Then you have routing, which provides routing and NAT and requires direct access and VPN RAS role service. And then you have web application proxy, which allows publishing web-based applications for use by clients outside the network. VPNs, or virtual private networks, are a network connection that uses the internet to give mobile users or branch offices secure access to a company's network resources. VPNs use encryption and authentication to ensure communication is secure and legitimate. A tunnel is a method of transferring data across an unsecured network in such a way that the actual data in the transmission is hidden from all but the sender and receiver. And that is created by using encapsulation. And here is your example of what that looks like. So you have your VPN client, internet, you got your nice little tunnel going whoop through the internet. It connects through the firewall, goes to your VPN server, and allows you to get into the company intranet. VPN tunnel types, routing and remote access service, or RRAS, supports 3 types of VPN tunnels. There's a point-to-point tunneling protocol, or PPTP, which encapsulates point-to-point protocol using a modified version of generic routing encapsulation, or GRE. Layer 2 tunneling protocol with internet protocol security, L2TP or /IPsec, generally provides a higher level of security than PPTP. And then there's secure socket tunneling protocol, SSTP, works behind most firewalls without administrator needing to configure the firewall to allow VPN. All 3 types are enabled by default when you configure Windows Server 2016 as a VPN server. After the remote access server role is installed, configure it in the routing and remote access console, which is accessed from the tools menu in Server Manager. Yeah, but I have a problem with, because I hear SSTP and I'm like, STP. If you've ever done anything with cars, there's it's an oil type. You're like, wait a minute, isn't that? No matter what type of work you go into, there's going to be acronyms that cross over. So just try to remember what they are or where you can look them up. All right, VPN requirements. Your server and network must meet requirements for the type of VPN you want to set up. 2 or more NICs installed on a server, correctly configured firewall. I cannot stress enough. Make sure your firewall is configured correctly, because otherwise it will not allow the person in, or it will allow too many connections in. There's a whole mess of problems you can have if you don't configure your firewall correctly. Authentication, and then there's DHCP configuration. Network firewall configuration for VPN. So configuring the perimeter network is crucial for VPN operation. The perimeter network is a boundary between the private network and public internet, where most resources available to the internet are located. The firewall must be configured to allow certain types of traffic according to the VPN tunnel type. And then in the book 229-230, there's a list of traffic per tunnel type that you can look up. All right, looks like we got a nice big pile of VPN configuration. So if VPN server is a domain member, its computer account must be added to the RIS and IAS server group in Active Directory. Next, click server icon and click configure and enable routing and remote access. The configuration window will give you options for the type of remote access server you want to configure. For a standard VPN server, select remote access, dial-up, or VPN option. And then looks like we'll get some nice figures here. Okay, so here's your figure. And then you have that top one they were just talking about, remote access, dial-up, or VPN. In the VPN connection window, select the interface that connects the server to the internet. You can rename network connections. The enable security on the selected interface by setting up static packet filters option is enabled by default. This prevents the interface connected to the internet from accepting any traffic that isn't part of a VPN connection. I highly suggest that you leave that alone and just leave it there. The IP address assignment window, you decide how VPN client connections are assigned IP addresses. Automatically is the preferred option. Okay. And here you can see on this one for VPN connection, you have internet and private net, and then you have your little connection stuff there. And then you have your nice check mark for the enable security on selected interface. On this one, you see the automatically, or if you want to do from specified range of addresses, you can do that as well. Next, you decide how clients are authenticated to the VPN server and whether you want to use Radius to handle authentication. After you click Finish, in the summary window, you see a message stating that you must configure DHCP relay agent. Do this if you configured automatic IP address assignment and the DHCP server is not on the same subnet. So remember that previous slide, if you haven't hit automatic on that one, and it's the DHCP is not on the same subnet, then that's what they're talking about. And here you go. This is the one they were just talking about here. You can do no, use routing or remote access authentication, or yes, set up the server to work with a Radius server. So the nice thing about most of these wizards, they walk you through step by step. And one thing that I always cheat on for me is I either have a tablet or my phone with me when I'm doing this, or, you know, if it's on a virtual connection, I have multiple windows up so I can open multiple things up at the same time. So if I'm like, I don't know if I want to use this, what do I need to go look at? I can pop up multiple windows and check them out. It's not cheating. It's called using all of your options, all of your resources. Okay, finishing VPN configuration. After finishing the RRAS setup wizard, the VPN server is ready to start accepting VPN client connections. You need to define who's allowed to connect. Two ways to allow users to connect via remote access are configuring dial-in settings in user accounts or configuring a network policy in the network policy server or NPS console. Configuring dial-in settings in user accounts. Okay, configuring each user account properties in Active Directory or local users and groups to allow remote access. In the account's property dialog box, click the dial-in tab. By default, network access permission attribute is set to control access through NPS network policy. Select the allow access option to give the user permission to connect remotely via dial-in, VPN, and direct access. So here's that right here on the dial-in page, on the dial-in tab. And then you can do allow access, deny, or control through NPS. And then you can go through all the rest of that there. VPN client configuration. The VPN client is configured by setting up a new connection in the network and sharing center. Choose connect to a workplace and choose how you will connect. Next, enter the address of the VPN server you connect to and enter a name for the connection. When you create a VPN connection, the default tunnel type is automatic. The VPN client attempts to make the connection by using each method until it's successful or the connection fails. So here's your new VPN property, user connection, all user connection, and you can see you just chug along through that. Configuring remote dial-in. Servers supporting remote dial-in must have one modem connected to a phone line for each simultaneous remote access user. And most places don't even have this option anymore, but you never know. Remote dial-in is configured almost the same way as VPN configuration. In network selection window, choose the private network from which dial-in clients are assigned an IP address. Remote dial-in has largely been replaced by VPN and direct access in Windows environments. In fact, I have not worked somewhere that's had a live dial-in for at least the last 10 years. Configuring remote access options. RRAS allows multiple tunneling types by default for VPN connections. You may want to consider restricting connections to a particular tunneling method. In fact, I highly suggest you do. Sometimes it's better to get more granular because the more things that you allow, the more variation you allow, the more difficulty that you will have in managing that. So if you can clamp down on it, as far as your IT department is concerned, then it gives you a little bit more ability as a network administrator to say, okay, this is how you have to do this. And a lot of times they'll when you're doing a VPN, that especially in a work environment, they're like, this is the exact client that you have to use in order to do this. And here are the, you have very specific things that you have to do. You can't just use anything to get in. You can configure remote access settings in the properties of the user account. This method can prove inefficient if many users need remote access permission. A lot of places, they don't do this unless you have a section like that has a much higher, like if you have a one that you want to have only like one section do something like this, but a lot of places do things by policy because rather than having to go in and change client by client by client, but for each user, it's easier to go through policies. Instead, allow or disallow remote access to users based on connection-related group policies. It's just significantly faster. Configuring remote access security. To configure security settings for remote access, right-click the server in the routing and remote access console and click properties. In the security tab, you can configure authentication provider, authentication methods, account provider, allow custom IPsec policy for L2TP IKE v2 connection or SSL certificate binding. And here's your window that shows you all your nice little tabs and what that looks like. Configuring available tunneling types. By default, each tunneling type is enabled in the RRAS service when you configure a VPN. Each type allows up to 128 connections or ports. Configure the number of ports in the routing and remote access console by right-clicking ports and clicking properties. Double-click a tunnel type to see the configure device dialog box. Changing the number of ports to 0 effectively disables the tunnel type. So if you have a tunneling type that you want to use, but you don't want to use any of the other ones, set all the other ones to 0 so that you don't have those functioning. So say that you only want to use that L2TP, set the other ones to 0. Does that make sense? Are we still awake? Yes, yes, okay. Configuring network policies. User account's network access permission attribute is set to control access through NPS network policy in the dial-in tab of the properties dialog box. By default, NPS network policy disallows all remote access. You must change the network access permission attribute to allow access on user accounts. You can also configure an NPS network policy in network policy server console. And then you have all the steps for that on page 238 of your text. I highly suggest that the more you can use policy and groups, the more you do that. Even if it's just for a small group of people, it's still better, because if someone quits and you're doing it user by user, you have to go in, and every time someone new is added, you have to go in and do that. Whereas you can just add new users to a group and keep all the same stuff on that group. Otherwise, it's much easier. Hey, guys, don't fight over the top of the laptop. Configuring VPN Reconnect. VPN Reconnect is a feature that automatically reestablishes a VPN connection that is temporarily lost with no intervention from the user. This feature is supported only on IKE v2 based VPNs on Windows 7 and newer clients, and Windows Server 2008 R2 and newer VPN servers. Creating connection profiles. VPN connection profiles allow you to create VPN connections that can be distributed to users' computers so that VPN clients do not have to be configured on each client station. Some features available with VPN profiles in Windows 10 and later: app trigger, always on, name-based, lockdown VPN, and traffic filters. Connection profiles are created with Microsoft Intune, System Center Configuration Manager, or the Configuration Manager Administration Kit, CMAK. Configuring a site-to-site VPN. Site-to-site or S2S VPN securely connects two networks. The VPN tunnel is established between two network devices such as routers or Windows servers configured as VPN servers. To configure an S2 VPN Windows Server 216, you've got steps on 241, and you can see this. It looks almost exactly like what they were talking about with the VPN tunnel, but instead of just having one client and then all the intranet on the other side, you can see it's just basically like a mirror on like just a different branch going through this VPN tunnel. Configuring IPv4 and IPv6 routing. Using RRAS and Windows Server can be configured as a router to connect multiple subnets and a network to connect a network to the internet. Windows Server 2012 R2 supports static routing and dynamic routing with Routing Information Protocol version 2, RIP-v2. To configure a server as a router, select Custom Configuration option in the configuration window of the RRAS Setup Wizard. Then select LAN Routing option. By default, only IPv4 routing is enabled. If you want IPv6 To route IPv6 packets, right-click the server in the routing and remote access console and click properties. Then in the general tab, click your IPv6 router checkbox. So here is an example of what that would look like for the RRAS server configured as a router. Routing tables, yay. Routing table is a list of network destinations and information on which interface can be used to reach the destination. The routing table has the following columns: destination, network mask, gateway, interface, metric, and protocol. And this is what they look like. That's why you heard me say, yay. Anyone who's ever had to stare at routing tables, it can get painful. So you can see your destination, your network mask. A lot of the times you'll see the 255, and then your gateway, your interface. You see there's Ethernet, Ethernet 2, loopback. You have your network metric, and then protocol. Configuring static routes. After routing is enabled, you can add routing protocols and configure static routes. Static routes instruct the router where to send packets destined for particular networks. An IPv4 static route has the following information: interface, destination, network mask, gateway, and metric. Sound familiar? Yep, that's why. So as you can see down here in the routing table, they're just showing you that this is the static and what it looks like when it's on the routing table. Configuring routing information protocol. In the RRAS console, under the IPv4 node, right-click General and New Routing Protocol, select RIP version 2 for IP. Next, configure RIP by enabling it on interfaces that RIP uses to send and receive routing information. RIP v2 uses the hop count metric for determining best path. Hop count is the number of routers a packet must go through to reach the destination network. Configuring IPv6 routing. Windows Server 2016 and up also supports IPv6 routing, configured largely the same way as IPv4 routing. However, there is no version of RIP for IPv6. Dynamic routing is supported using Border Gateway Protocol, or BGP. You can create IPv6 static routes in a manner similar to creating IPv4 static routes. You can also use the route add command using --6 option and the new net route PowerShell commandlet using address family IPv6 option. And this just shows, as you can see, it looks very, very similar to the IPv4 static route. Configuring border gateway protocols. BGP is an advanced dynamic routing protocol that can be used to route between remote networks. It is much more complex than RIP v2. BGP can be configured on a computer running remote access server role using the remote access PowerShell commandlets. And then there's, to see a list of remote access PowerShell commandlets, these are my favorite commands, are the ones to tell you how to find things. So get command module remote access, and then to see commands specific to BGP, get command *-BGP*. So those are some really nice, helpful ones that I would suggest if you're going to be doing them. It's just like anything else where you're doing listing, knowing where the help and what listing of those are is really helpful. It's funny, I prefer Linux over PowerShell as well. I know PowerShell is used a lot, but I feel like for me, Linux always seemed a little bit more straightforward than PowerShell did. So personally, that's what it looked like. In my opinion, same, I prefer Linux. Configuring network address translation. So NAT, or network address translation, is a process where a router or other gateway device replaces the source or destination IP address in a packet before forwarding the packet. So that's why it's called network address translation. It's used to allow networks to use private IP addressing while connecting to the internet. Port address translation, or PAT, allows several hundred workstations to access the internet with a single public internet address. Use source TCP or UDP, not B, port numbers in addition to IP addresses. To configure NAT in the RRAS setup wizard, select network address translation option in configuration window. For LAN-based internet access, choose the interface connected to the internet in the NAT internet connection window. If the internet connection is dial-up, which I really hope it's not, choose the option to create new demand dial interface to the internet. So here's your example of private public, where it's talking about NAT. And basically, the reason NAT was created was because we were running out of IP addresses. So it allows all of those ones that we use internally, use that RRAS server for NAT to reach out on one public facing IP address to reach the internet. And it just saves much more space using NAT. Direct access role service. Direct access provides many of the same features as a VPN, but adds client management and always connected capability. Direct access uses IPv6 and IPsec to create secure connections to the network. Direct access almost eliminates client connections problems caused by firewall settings. Direct access requirements. Direct access basic requirements in Windows Server 2016. You need 2 NICs, like you do for a VPN server. Server must be a domain member, and it must have a public IP address. There is an option for direct access to use Kerberos proxy for authentication and encryption. Kerberos proxy allows a client computer to authenticate to a domain controller using the direct access server as a proxy. Optional server configurations. List of recommended enhancements for production environments. Internal PKI. SSL certificate issued by a public CA for IP HTTPS. SSL certificate issued by an internal PKI for network local location server. Computer certificate issued by an internal PKI for IPsec authentication, or 2 consecutive public IP addresses. So the reason you would want 2 consecutive public IP addresses is just to allow a little bit more throughput if you've got a ton of users that are using the intranet internet connection and NAT translation. Direct access client requirements. No special software needs to be installed on clients. Requirements for direct access clients must be running at least Windows 7 Enterprise or Ultimate or Windows Server 2008 R2. Client must be a domain member. Notice a trend here, must be a domain member. IPv6 must be enabled on the client. How direct access connections work. The following basic steps explain the process. So step 1, direct access client computer detects that it has a valid network connection. Step 2, using the NLS server, the client determines if it is connected to the internet or the main network. If it isn't connected to the main network, the process continues to the next step. Step 3, client attempts to connect to the direct access server via IPv6 and IPsec. Step 4, client and server authenticated with each other using computer certificates issued by PKI or Kerberos proxy. Installing and configuring direct access. Follow the steps on 256 to install a test network similar to the network below. And that's if you want to create something like this. And it's just so that you can set this up and do it on your own. Advanced direct access deployment options. After you've enabled a basic direct access configuration, you might want to add some of the following features for security and convenience. set up a PKI, configuring NLS on a separate web server, configuring the NRPT, configuring forced tunneling, and configuring intra-site automatic tunneling addressing protocol, or I'm not even going to try to shorten that one. So that thing. Setting up a PKI. So step one, on a server separate from the direct access server, install AD certificate services configured as an enterprise certificate authority. Step two, issue an SSL certificate to the NLS server set up on a server separate from the direct access server. Step three, issue machine certificates to the direct access server and each direct access client computer. It is best to configure auto enrollment so that each client computer can automatically request and be issued a machine certificate. Configuring NLS on a separate web server. You need IIS installed on any server in the network. Direct access clients connect to it with HTTPS, so it requires an SSL certificate. Make sure a DNS record is created on internal DNS servers that points to the NLS server using a name. The name is published to direct access clients with a group policy. Remember my thing about use policies as much as possible. So they're pointing out some other reasons why you want to use that. Configuring the name resolution policy table. When direct access clients are connected to the internet, the name resolution policy table, or NRPT, makes sure DNS requests for network resources are directed to internal DNS server. You may need to create NRPT exemptions for certain cases, referred to as split brain DNS. And then if you want to go look up the steps, are on page 262. Configure forced tunneling. I mentioned this previously. The default direct access client configuration is split tunneling. Split tunneling is a remote access method in which only requests for resources on the network are sent over the direct access tunnel. If you configure forced tunneling, all traffic from the client goes over direct access tunnel. So split tunneling is only for certain resources, and forced tunneling means everything goes through. You configure forced tunneling by using group policies with the same procedure for configuring NRPT exemptions, but enable route all traffic through internal network policy. And configuring ISA-TAP. ISA-TAP, I'm going to have to say that a lot, fun, allows computers on the network to access direct access clients that are connected via the internet. Two ways to enable it on the network are enable it for all computers on the network or enable for only certain computers. To selectively enable, create a DNS record using the IP address of direct access server's internal interface, create a security group and add computer accounts you want to enable ISA-TAP, create GPO and enable this policy. Computer configuration policies. Oh, this one's a fun one. Policies, administrative templates, network, TCP/IP settings, IPv6 transition technologies, and set ISA TAP router name. And the enter a router or relay name text box, type the name of the DNS record you created in step one, and then enable ISA TAP state policy setting. All right, now that your brain's melted, we're at the end of this one, and then we will move on to the next one. Though I am going to stop for just a second to let you guys breathe. Do you have questions on that other than, ow, my brain? No, my brains. Yeah. Crying time. All right. So that was 6. We are going to do 7 tonight. But that one's 29, even with a lot of other stuff. And this one's network policy server. So that way we'll have, yeah, go ahead and take 5-10 minutes. I'm going to pause the recording. Okay. We have resumed our recording, and we are going to do the next one, which is short, which is implementing network policy server. All right, so network policy server overview. With network policy server, or NPS, you can define and enforce rules that determine who can access your network and how they can access it. The NPS architecture includes 4 features: radius, which we've talked about a couple of times, radius proxy, and radius accounting. Radius infrastructure, network policy server, Microsoft's implementation of remote authentication dial-in user services, or radius protocol. Access client is a user or device attempting to access the network. Network access server, or NAS, is a protocol-specific device that aids in connecting access clients to the network. Wireless access point, or VPN server. In the radius infrastructure, a NAS is configured as a radius client. An access client makes a connection request to a NAS. The radius client sends an access request message to an NPS server, acting as a radius server. The NPS server evaluates the access request message. The NPS server can respond with one of 3 types of messages: access reject, request is rejected; access challenge, more information is requested; or access accept, that is just basically the access is granted. The NAS sends an accounting request message to NPS server to be logged. The NPS server sends an accounting response message, which acknowledges the request was received. During the session, additional accounting request messages containing information about the current session are sent. When the user's connection ends, one last accounting request message with information about the overall use during the session is sent. Final message is acknowledged by accounting response message. A radius proxy can be inserted between NAS and NPS servers to help manage the load on NPS servers. Reasons for radius. Radius centralizes control over authentication and authorization. Standardizing on radius requires all NAS devices to be radius clients so that only one protocol performs authentication and authorization. So here is radius, a nice big mess of radius infrastructure, but it actually does give you a pretty good example of what that would look like with radius servers, radius proxies, and then you have your domain controller, radius account server, and then all your various user ones out there as well. Installing and configuring NPS and radius. 2 reasons to set up an NPS architecture with radius when you have different connection paths to your network. Radius centralizes control over authentication and authorization. Standardizing on radius requires all NAS devices to be radius clients. After NPS is installed, you can configure the server to be a radius server, radius proxy, or both. The NPS standard configuration has wizards that walk you through these policy settings. Radius server for dial-up or VPN, radius server for 802.1x wireless or wired connections. A policy must be defined for each type of radius client, such as VPN NAS, in the NPS console. Communication between a radius client and a radius server is validated with a shared secret, a text string that acts as a password between radius client server and proxies. Guidelines for creating shared secrets should be at least 22 characters and should include uppercase, lowercase, letters, numbers, and symbols. Can be up to 128 characters. Use a random combination of letters, numbers, and symbols rather than a phrase. So this is where you use your random password generators and just go for it with those. Depending on the type of NAS, 2 general types of authentication methods are used: password-based and certificate-based. 4 password-based methods are supported: Microsoft challenged handshake authentication protocol, MS-CHAP, MS-CHAP version 2, challenge handshake authentication, CHAP. Okay, I'm not even going to make it through that one. Or password authentication protocol, PAP. Certificate-based method is extensible authentication protocol, or EAP. Certificate-based authentication is more secure than password-based authentication. The authentication type for EAP is TLS. You remember us talking about that. Protected extensible authentication or PEEP is a special way to encrypt a password being sent via MS-CHAP2. Another part of the network policy is the realm, the Active Directory domain where the Radius server is located. A simple Radius infrastructure in a large network has a few drawbacks: lack of fault tolerance and possibly overloading the Radius server. A solution is to use Radius proxies with multiple Radius servers or Radius server group. In a server group, the load can be balanced based on these properties: priority, weight, and advanced settings. Configuring Radius accounting. Radius accounting is a log of the different access and accounting requests and responses between Radius clients and Radius servers. NPS logs requests and responses by using one of these methods: event logging, a local text file, or Microsoft SQL Server XML compliant database. The default setting is to log the account information in the local text file, which is the System32 log file in Windows. Using certificates for authentication. For stronger security, certificate-based authentication is recommended. A certificate is I can't believe they put this in here. Hey, did you guys know a certificate is a digital document containing information that establishes an entity's identity? Wow. With this authentication method, a server or client's identity can be verified. Certificates are created. I can't believe this. Like we haven't been through this already. Certificates are created and distributed by our certificate authority. Then you have our two types that we've talked about, public and private. And then for a certificate to be used for authentication, the certificate must be trusted by the client or server. And remember us talking about the root certificate? Yes, there we go, root certificate. I know. So much sarcasm. Okay, three other important cert types. Client computer certificate, which verifies a client's computer identity to an NPS server. Server certificate verifies the server's identity to a client. And then user certificate can be put on a smart card to verify user's identity. Certificate must meet these three criteria. It must be valid, it must be configured for the purpose it's presented, and it must be issued by a trusted CA. For a client to accept a certificate, the certificate must meet these requirements. Subject to name can't be blank. Certificate is linked to a trusted root CA. Purpose of the certificate is server authentication. Algorithm name is RSA, and minimum key size is at least 2048. If the subject alternative name extension is used, the cert must contain the NPS server's DNS name. Configuring NPS policies. NPS policies define who can connect, when they can connect, and how they can connect to a network. Two policy types are available: connection request policies, which specify which Radius servers handle connection requests from Radius client, and network policies, which specify which users and groups have access and the times they have access. Configuring connection request policies. Connection request policies are used to specify which Radius servers perform authentication and authorization of Radius clients' connection requests. Can also specify to which servers Radius accounting requests are sent. You can define connection request policies for the following NAS types: unspecified, remote desktop gateway, remote access server, which is your VPN dial-up, or vendor specific. When Radius server receives a Radius access request message from a Radius client, the client's attributes are checked against the connection request policy's conditions. Attributes in the access request message must match at least one of the conditions in the policy before the NPS server acts as a Radius server or a Radius proxy. Creating conditions allows you to control who can access the network, how they access it, and when they access it based on the NAS that the client is using to request access. The following groups of condition attributes can be used: in connection request policy to compare the attribute of the radius access request message. Username, connection properties, date and time restrictions, radius client properties, and gateway properties. Configuring network policies. Connection request policies are specific to a NAS type, but network policies affect all clients who are trying to connect. Groups of conditions for determining access. Groups, day and time restrictions, connection properties, radius client properties, and gateway. In addition to network conditions, you can specify network policy constraints. Constraints are similar to conditions with one major difference. If a constraint doesn't match the connection request, no further policies are checked. You can configure the following constraints: authentication method, idle timeout, session timeout, called station ID, day and time restriction, and NAS port type. Configuring network policies for VPNs. The authentication type for a VPN can be password-based or cert-based. Cert-based are more secure, but you must have a valid CA cert installed on every computer connecting via the VPN and client certificates installed on each computer. Network policy settings that are applicable to VPNs, multi-link and bandwidth allocation BAP, handle connection types that include multiple channels. Whenever I hear BAP, for some reason, I just think of a cat smacking somebody in the head, but that's just me. IP filters, filter access based on client's computer IP address. Encryption settings, specify which encryption strength should you allow. And then IP settings adjust how IP addresses are assigned to the access client. Managing NPS and radius templates. Templates can reduce the amount of work and minimize the chance of error, especially when many radius servers and clients need to be configured. Templates are in the Network Policy Server console under Template Management node. There are 4 template types: shared secrets, radius clients, remote radius servers, and IP filters. Exporting and importing templates. NPS can export templates to an XML file that can then be imported to another NPS server. To export a template, open the Network Policy Server console, right-click Templates Management, export templates to a file. Select the location for the file, enter name, and click Save. Import the template, open Network Policy Server console, right-click Templates Manager, and click Import Templates from a file. You can also click Import Templates from a computer and enter the name of another NPS server on your network. Importing and exporting NPS policies. After configuring policies templates, you can back up the entire NPS configuration by exporting it to an XML file, which is not a bad idea, because once you get it all figured out and you want to have a baseline, you can export it just in case, you know, something happens and something gets messed up. You can go, oh shoot, I need to, you know, go back to that baseline and import it again. To export an NPS backup file, follow these steps in the Network Policy Server console. Step 1, in the left pane, right-click NPS node and click Export Configuration. Click OK. Step 2, choose a name and location to save the XML file and click Save. Step 3, to restore the configuration, right-click the NPS node and click Import Configuration. And then to export an NPS backup file from the command line, follow these steps. From the command prompt, type netsh, press enter. At the netsh prompt, type nps, press enter, then type that whole thing there. To import the file on the server in another style, type netsh and press enter. Type nps, press enter, and then you have that nice string right there as well. Okay, we are done. Let me hit stop share. All right. Are there any questions? Okay, I'm going to hit stop.